Welcome to the Math Record. In this video, I'll be covering the third part of the ICTM Regional 2015 Division AA Precalculus, which I'll be answering questions 18 and 20. Okay, question 18. When written out as an integer, 2015 factorial has k trailing zeros. Determine the value of k. So basically, we need to find out what a trailing zero is, which is basically just 2000, let's say 2500 as an example, has two trailing zeros, but 2501 has no trailing zeros because the last one ends at 1. So it has to end at zeros and basically just something like that. So how many trailing zeros are in 2015 factorial? Well, how do we get a zero at the end? Well, as if you think about multiplying, that's just 25 times 10 times 10. To get these tens, right, is 2 times 5. So which one do we look for, 2 or 5? Well, if you think about it, we have to look for the 5s. And the reason is because if we think about factorials, it would be 1 times 2 times 3 times 4 times 5, right, etc. So every single two numbers, we should have an even, right, which gives us our 2. But every single five numbers, we get a 5. So since 5 occurs less often than 2, that means we have to look for the amount of 5s because the 5s limits the amount of tens we can make because we need a 2 and a 5 to make a 10. So we just had to look for the 5s because that's the one that's limiting the amount of tens we can make. So in 2015, how do we look for the amount of 5s? Well, we have 2015 divided by 5, and that will give us the amount of, because every single 5 numbers should give us a 5, right? So that makes sense. But also, we have 2015 divided by 25, because every single 25 numbers should have an extra 5, right? Because 25 divided by 5 divided by another 5 should still be an integer, because 25 is made out of 5 times 5. And then going by that logic, 2015 divided by 125, which is just 25 times 5, that means every single 125 numbers should have another additional 5. And by the same logic, 125 divided by 625 should give us every single 625 numbers should have a fourth additional 5. And then we could keep going by this, but then it would just be higher than 2015 because 625 times 5 is 3125, which is higher than 2015. So basically, we need to stop there. So we have 2015 divided by 5, 2015 divided by 25, 2015 divided by 125, and 2015 divided by 625. And if you use your calculator to calculate all of these and add up only the integer parts, you should get an answer of 502. And that's your answer for number 18. And that's a logical way to think about it. Okay, question 20. In the diagram shown, CD bisects angle ACB and triangle ABC. Cosine of theta equals 1/4, and 1 over a plus 1 over b equals 1 over 20. Determine the length of CD. So let's just draw something like this. Theta, theta, and we have a, b. So we could use the angle bisector theorem, which gives us that if we bisect an angle, the side lengths should be in the ratio ax, bx, right? So under the a is the a, under the b is the b, and then we have x for the scaling factor. So how do we find the length of CD? Well, we could call this length d, and then we could just use the law of cosine. So that would give us a squared plus d squared, right? We're just focusing on this triangle, and then we're going to focus on this triangle. So a squared plus d squared minus 2ad cosine of theta. Cosine of theta is 1/4, so 1/4 times negative 1/2 is negative 1/2. Negative 1/4 times 2 is negative 1/2, and then ad, which equals to a times x squared, which is also a squared times x squared. And then from here we have the other triangle, which is b squared plus d squared minus 1/2 ad, 1/2 bd cosine of theta, 2bd cosine of theta. Cosine of theta is 1/4, so 1/4 times negative 1/2. Negative 2 is negative 1/2 also. So negative 1/2 bd is equal to b squared x squared. So I just used cosine of theta twice for these two triangles. And then basically what I would like to do is that I want to eliminate these variables. And the reason is because we have d and a and b. So there seems to be too much variables here. So let's just eliminate them because it's going to get too complicated. So we're going to multiply the first one by b. So that's a squared b plus b d squared minus 1/2 abd. equals to a squared bx squared. And then this one we'll multiply by a, so ab squared plus ad squared minus 1 half abd is equal to a b squared x squared. So now we could subtract the equation by each other so that we could eliminate these variables. So we have a squared b minus ab squared plus bd squared minus a d squared is equal to a squared b x squared minus a b squared x squared, right? And then what I'm going to do here is that I like to move everything to one side. So I'm going to move everything here. So then this is positive. So when you move it here, it becomes negative. This is negative. So when you move it here, it becomes positive. So I'm just going to eliminate this equal sign. So I don't have to rewrite this again. So this makes it a negative and this becomes a positive and it's equal to 0. So this seems complicated now, but I noticed that there's A's and B's everywhere for like each term. Well, but it's kind of separate for some of them. But basically, all we have to do is just factor out similar factors. So a squared b and ab squared, you can factor out a and b. So this leaves a minus a b. And then bd squared minus ad squared, we need to get a minus b. So we need to factor out a negative d squared. So this here, we get a minus a b. And then same case here, we need to get a minus a b. So then we can factor out a negative a b x squared. So then we get a minus b is equal to 0, right? So from these two terms, these two terms, these two terms, I get a minus b, a minus b, a minus b, and then a bunch of the other factors. So then together, we could rewrite this as a minus b times ab minus d squared minus abx squared is equal to 0. So that means a minus b is equal to 0, which is probably not true because a is not equal to b. Or we could say ab minus d squared minus abx squared is equal to 0, which seems more true. So let's delete all this because we don't need it anymore. And then we just need to focus on this equation. So what does this equation give us? Well, we need to find d, right? So we could rewrite this as ab minus abx squared is equal to d squared. So let's delete this. And we just need to find out x squared because then we can plug in this equation to get d squared. So, well, we could now focus on this entire triangle by itself and use the law of cosine, which is a squared plus b squared minus 2ab cosine of not theta is 2 theta now because it's the entire triangle is equal to ax plus bx squared, which is also just a plus b squared times x squared. So now we have So let's just focus on cosine 2 theta first. So cosine of 2 theta, if you know your trig identities, is just 2 times cosine squared theta minus 1. So 1/4 here, so 1/4 squared is 1/16. 1/16 times 2 is 1/8. 1/8 minus 1 is negative 7/8. And then negative 7/8 times negative 2 is equal to positive 7/4. So we have a squared plus b squared positive 7/4 AB, right? There's still this AB is equal to a plus b squared times x squared. And we could rewrite this as a plus b squared, which is a squared plus b squared, which is these two terms. But we also have an extra plus 2ab. To get from 2ab to 7/4 ab, we got a minus a 1/4 ab, 1/4 ab, which is equal to our a plus b squared, a plus b squared times x squared. So then to get x squared, we just divide both sides by a plus b squared, which a plus b squared divided by a plus b is squared is 1 minus 1/4. And then we have our ab, a plus b squared is equal to x squared. And now we can plug this in into here and we should get our answer. So let's delete all of this. So this is just a lot of math to like find relationships between stuff. So right here, we just factor out our a times b. So this is just 1 minus x squared is equal to d squared. So we have 1, which we could substitute this into here, right? So then this would just be 1 minus a 1. So that would just cancel each other out. And then minus a negative makes this a positive. So this would just be ab times 1/4 ab over a plus b squared. And that would be equal to our d squared, right? So this would just come out as 1/4 times a times b times a times b is a times b squared over a plus b squared is equal to d squared. So this is what we need to find out. And we already have all the information to get the value of d squared. So just delete all of this. And now just find out this value. So what does this give us? Well, we already know 1 over a plus 1 over b is 1 over 20. And if you simplify it, it's just a plus b over ab to get the same denominator, it's just 1 over 20. So if you think about it, just flip the top and the bottom. So that would just be the same thing as ab over a plus b is equal to 20, right? ab plus a over b, and they're squared. That means it's just 1/4 times 20 squared is equal to d squared. So this will be 400. 400 times divided by 4 is 100, which is equal to d squared. That means d is equal to 10. And that is your answer for number 20. Well, thanks for watching, and I'll see you at the next math record.